Hi everybody, this is our movie on molecules and chemistry, and I want to apologize for you having to listen to me on that. Unfortunately, the PhET simulation that this is won't run on our Chromebook, so you have to listen to me. We spent the last couple of activities working on atoms and what constituted atoms, and we talked about the periodic table. Now we're going to be moving into chemistry. And chemistry is basically the science of how all the atoms go together to make all the different things in the world that we see. We have 94 different elements that are naturally occurring that make up everything that we know of in the universe, including us. And that's pretty tremendous. So what we want to do in this activity today is we want to learn how to read and write chemical names, understand the difference between a molecule and a compound, even though it's a pretty small difference, and just some other basic chemistry concepts. So we're going to start here by building some molecules. And again, molecules are collections of atoms. So the very first thing we're going to do is water, which is H2O. You can see the H is for hydrogen, and the O is for oxygen, and the subscript tells us the number. So there we've got a O and two H's, and that makes our water molecule. And I'll show you one other thing just so you're aware of it. We're not going to ask you this on the test, but there's a couple different ways that atoms get shown in textbooks. One is space filling, which is this, where it just kind of ran everything together. Really probably is more realistic in what they really look like, although all these are just representations. Probably the more common one, though, is a stick and ball representation. This is probably most used in science books because it lets us tell what's happening with the electrons, which is we'll get to later on this year. But I just wanted you to see those two, stick and ball versus space filling, because you see those all the time. This is a molecule, and it's also a compound. It's both. Our next thing, however, though, which is just oxygen gas, this is not a molecule, but it is a compound. So this is both, this is just a compound. Same with the hydrogen gas right here. Two hydrogens go together, there's hydrogen gas. It is also a compound, but not a molecule. Now we're going to go ahead and do CO2, carbon dioxide, and there's a carbon, and here are two oxygens. And this again is both a molecule and a compound. And then finally, nitrogen gas will only be a compound. So we have molecule and compound, only compound, only compound, molecule and compound, and compound. And as a matter of fact, all molecules are also all compounds, but not all compounds are molecules. So one of the questions is to try and figure out what would make something a molecule and a compound versus just a compound. Now, all of these here also have their chemical names written out here: H2O, O2, H2, CO2. These are all very simple compounds. And we want to talk a little bit about what you need to do for that. So here is some more complicated molecules. The first one is table sugar. And you can see it is made of carbon, hydrogen, and oxygen. And it has 12 carbon, 24 hydrogen, and 11 oxygen. Those little subscripts there tell us the number of the atoms that are in the molecule. So if I ask for the total number of atoms in this, it'd be 12 plus 24 plus 11. Down here is sulfuric acid. Now this one looks a little different because you can see that the S right here does not have, the S for sulfur here has no number next to it at all. And if it has no number next to it, you just assume it's 1. So again, on this, if we want you to be able to identify that it's got hydrogen, sulfur, and oxygen in it. And that it was made of 2 plus 1, 3 plus 4, 7, 7 total atoms. Now, we're not going to get you too much with this because they can be kind of tricky. There's rules for writing these chemical names, but there are a lot of exceptions to those rules. It's like English, but one of the rules is pretty consistent, is if carbon is present, it is always going to be first. No matter what else is in there, carbon is going to be first, and that's because carbon is a very important element to all living things. It's kind of the atom glue that holds together all living material. And hydrogen is always second. So you can see in table sugar we have carbon and hydrogen, so carbon came first, hydrogen came second, and then we had the oxygen. And if in this one we have hydrogen first because we don't have any carbon in there, but carbon and hydrogen are two really important elements to we humans or any life form, so we always put them first. And then after that, you just do them alphabetically. But you can already see here's an exception to that because S does not come before O in the alphabet. They put S there because it doesn't have a subscript, and then they did O. We're not going to really be concerned with what we're doing right now that you can do an absolutely perfectly written chemical name. Here's what we will want you to do. We will want you to be able to identify the atoms that are present and the number of them that are in the total molecule. Okay? So, this is chloromethane. And you can see what it's made of here. And I'm not going to do anything other than just have you look at this. You may want to pause your computer and write the chemical name for this particular molecule. And then, when you're done with that, we'll want you to do the same thing with a little bit more complicated of a molecule, and that would be this one. This is a molecule of caffeine, which is in coffee. You can see it's a little bit bigger molecule. You can see the atoms that it's made out of, and you can see, you can count the number of them. So go ahead and write out the chemical name for this as well. Now the final thing I want to show you, I'm not going to have you write the chemical name for because it would be cruel, but I do want to make a point with it. Some molecules are just gigantic. And here's a good example of a gigantic molecule. This is one molecule of insulin. Insulin is has over 900 atoms that make every single molecule, and they all have to be in a very specific place. Insulin is very important for our regulating our body. Some people are diabetic and they have problems with doing this, and they have to take insulin to help them. And one of the amazing things about insulin is for years, if you were diabetic, the insulin that you got actually was pulled from live pigs. And that was the only place because their insulin was compatible with people, but it made it very expensive and also had times when it would run out. People, because they're ingenious, have learned to put together molecules like this on their own, and we now have man-made insulin, and we have for over a generation, and it was really beneficial to people that are diabetic because now that we can make it, we no longer have to get it out of live pigs. But the story of chemistry is really we have naturally occurring molecules. All of these are naturally occurring compounds. They're not all molecules. But people over about the last 100 years have gotten really good at putting molecules together in totally new ways to make totally new materials that, as far as we know, only occur on Earth, and they only occur on the Earth. We don't know of anywhere else in the universe they exist. Many of them are in your clothing. A great example of a man-made molecule is nylon, which is heavily used and has been for over 50, 60 years. Plastics, man-made molecules. We don't know of anywhere in the universe where plastics are present because we have to basically put them together, and chemistry is the part of science that deals with putting atoms together to make different substances. That's what chemistry is. So Hopefully that's a little basic primer, and now you know the difference between an atom and a molecule. Hopefully you know the difference between a compound and a molecule. Hopefully you can look at any chemical equation or chemical name, actually it's not an equation, but any chemical name, and tell me the types of atoms that are present and the total number of atoms in each one. Hopefully you can sort of write a chemical, a name for something, although like I say, there's a lot of exceptions in those rules, and hopefully you have a little idea of what the study of chemistry is all about. Thanks for watching.